Zoom session is being brought to you by the Fractal Horizon Forming. Okay, whoops, wrong one. There we go. For today, we'll be doing sections 1 and 2 of chapter 2. 2.1 is about functions, 2.2 is about graphs of functions. Okay, a function is a rule. It takes an input x and computes an output called f of x, f parent x n parent. Think of f as a box, a calculator like this is a box full of functions. Start with a number, you put it into f, out comes f of x. It's the moment Montoya is here. All right. Now the set of all possible inputs is called the domain of f. A set of all possible outputs is called the range of f. You find the value by evaluation and substitution and evaluation. For example, f of x equals 3x squared plus 2x minus 4. What's f of 0, what's f of 1, and what's f of negative 1? Well, for f of 0, you put a 0 in for x. 3 times 0 squared plus 2 times 0 minus 4. After a bit of arithmetic, that comes out to be negative 4. F of 1, you put in a 1 in for x. 3 times 1 squared plus twice 1 minus 4. Arithmetic gives you 1. F of negative 1 is 3 times negative 1 squared plus twice negative 1 minus 4. That gives you negative 3. Okay. Well, domains mean that f of x is defined. And the main problems will be division by 0 and square roots of negatives. Although when we get to complex numbers, we will allow square roots of negatives. But generally, we don't allow division by 0. The problem is that when you divide by 0, either you get an infinite number, which is to say no number at all, or you get an indefinite number, in other words, basically every number there could be. So for example, what are the domains of 1 over x squared minus 9? Well, we have to have x squared minus 9 is not equal to 0. That happens at plus or minus 3, so x is every value except plus 3 and minus 3. The graph is this line with these 2 points removed. G of x equals root of x minus 5. The potential problem is square root of a negative. So x minus 5 has to be at least 0, and x has to be at least 5. Its graph is including 5 and everything to the right of it. There's something they call the difference quotient. Given a point here on the graph, f by x by f of x, move over h, goes up to here, x plus h by f of x plus h. The difference quotient is the slope of this line. It's the change in f divided by the change in x. Change of f of x plus h minus f of x. Change of x is h. F of x plus h minus f of x over h. This is also denoted delta f over delta x. Delta f is a change in f. Delta x is a change in h. You'll be seeing a lot of this, a lot more of this when you get to the calculus. But I'll say a few things about it here. So for example, let's say f of x equals 2x plus 1. So what's f of x? F of 1, what's f of negative 2? What's f of a half? F of a, f of negative a, and f of the quantity a minus 1. Okay, f of 1 is twice 1 plus 1, that's 3. F of negative 2, that's twice negative 2 plus 1. Negative 4 plus 1, negative 3. F of a half is twice a half plus 1. That's 1 plus 1 is 2. F of a is 2a plus 1. F of negative a is negative 2a plus 1. F of a minus 1 is twice a minus 1 plus 1. After distribution and some arithmetic, it's 2a minus 1. And here they ask for, given f of x is x squared plus 2x, what's f of 0? What's f of 3? What's f of negative 3? What's f of a? What's f of negative x? And f of 1 over a. All right, f of 0 is 0 squared plus twice 0, which is 0. F of 3 is 3 squared plus twice 3, like this. 9 plus 6 is 15. F of negative 3 is negative 3 squared plus twice negative 3. That's 9 minus 6 is 3. F of a is a squared plus 2a. F of negative x, you put in a negative x in, you get negative x quantity squared plus twice negative x. That comes out to x squared minus 2x. F of 1 over a is 1 over a square that plus twice 1 over a, which after a bit of arithmetic comes out, or algebra comes out to 1 plus 2a, all that over a squared. Now they mentioned briefly in the book what's called a piecewise defined function. It's a function with different formulas that apply to different parts of the line. In this case, f of x equals x squared if x is less than 0, and x plus 1 if x is greater than or equal to 0. And what is it at -2, at -1, at 0, at 1, and at 2? F of -2, that's less than 0, so we use the x squared formula. So -2 squared is 4. F of -1, well, again, less than 0, so use -1 squared is 1. F of 0, well, at 0, that's greater than or equal to 0, so use this formula. 0 plus 1 makes 1. F of 1 will be 1 plus 1 is 2. F of 2 will be 2 plus 1 makes 3. The difficulty with this function like this is at the boundary between these two regions, f of less than 0 and f of greater than or equal to 0. Just below 0 would be like -1/10, be a 1/100th, but right at 0 it's 1, so there's a sudden jump at 0, a discontinuity. All right, find f of a plus h, and the difference quotient for f equals 3 minus 5x plus 4x squared. Okay, f of a just substituted in, 3 minus 5a plus 4a squared, that's easy enough. F of a plus h, you put in a plus h wherever the x is. 3 minus 5 times a plus h minus 4 times a plus h all squared. Distribute the 5, you expand this a plus h squared, distribute the 4, and you get 3 minus 5a minus 5h plus 4a squared plus 8ah plus 4h squared. And now the difference quotient, f of a minus f of a over h, f of a plus h minus f of a over h. Well, first, I'll bring this 1 over h outside. That's easier. F of a is this whole thing here. 3 minus 5a minus 5h plus 4a squared plus 8ah plus 4h squared minus f of a, 3 minus 5a plus 4a squared, just like here. Now here, the 3's cancel, the 5a's cancel, the 4a squareds cancel. We're left with -5h plus 8ah plus 4h squared, and this is all as times 1 over h. After the 1 over h cancels these h's here, you're left with -5 plus 8a plus 4h, and that's the difference quotient. All right, here we're talking about producing X yards of some kind of fabric, and the cost is $C, and it's given by 1,500 plus 3x plus 0.02x squared plus 0.0001x cubed. What is it at 10? What is it at 100? What is it at 0? And what do those mean? Okay, well, plug in 10, 1,500 plus 3 times 10 plus 0.02 times 10 squared plus 0.001 times 10 cubed. After some arithmetic, it's 1532.1. That's the cost of making 10 yards of this fabric. So you have 100, 1,500 plus 3 times 100 plus 0.02 times 100 squared plus 0.3001x 100 cubed. And after some arithmetic, that's $2,100. That's the cost of making 100 yards. And see at 0, well, 1,500 plus 3 times 0 plus 0.02 times 0 squared plus 3.0010 cubed. All these last three terms go away, and we're all left with 1,500. That's called the fixed cost of making no yards of fabric, just setting up the equipment. It's the initial investment that you have to make up before you can start turning a profit. Okay, that's it for this part.